Hello everybody, this is Mr. Shaban. Today we are going to talk about the unit of reactivity, specifically lesson 6.2 reactions of metals in water. Last time we have spoken about the reactivity in terms of metal comparison, and we have seen how the group 2 metals were higher reactive than the transition metals, and we gave an example of magnesium and iron. We have seen how the magnesium have given out a huge amount of energy when it's burned in oxygen compared with the iron that was a very slow reaction that takes up to months in order to react with the oxygen. In today's lesson, we are going to talk about the following: the group 1, how the group 1 metals react vigorously with water, how the metals nearest the bottom of group 1 in the periodic table are more reactive and react more vigorously than those on top. Some metals will react with hotter water or steam, but not with cold water. All of these are putting the metals apart from each others, and all of these discuss reactivity. So the lesson, the keywords of today's lesson is reactivity. Let's start first with the periodic table. As you can see, we have earlier we have taken group 2 and we compared magnesium with iron, but right now we're going to talk about mainly group 1. Okay, group 1 is classified as the most reactive metal found in the periodic table. Specifically, as you go down, the francium. Francium is the most reactive metal found on Earth. Francium is way too reactive, so as you go down, the reactivity of the group 1 increases. Here is lithium is the lowest reactive group 1 metal, and francium is the highest reactive metal found on Earth. There is one point I'm not sure, do you have you noticed that or not, but hydrogen is placed over here. Hydrogen is placed over here, as I have told you earlier. It's not a metal, but for the sake of keeping the order of the elements in the periodic table. It has only one atomic number, so we have placed it over here, but it's not a metal, it's a non-metal. So you need to exclude the hydrogen out of your calculation. We're starting with the first metal of group 1, which is lithium. Okay, so as you go down, reactivity increases until we reach to francium. So I want you to remember a fact that as you go down as well, the hardness of the metal might change, because you still, if you remember that sodium was very soft and you can cut it with a knife. So that's a difference between group 1 metal along with the transition metals as well. You're going to see a picture how these metals react differently with the water. So as you go down, the reactivity increases, and that's what is going to give you a clue right now. That's a piece of lithium placed in the water. As you can see, it doesn't produce a fire, but it reacts very slower when it's compared with sodium and potassium. So that's the least reactive group 1 metal. Sodium bursts into fire because it's higher reactive than the lithium. When you place it in the water, it's going to react vigorously. And potassium has produced a huge amount of energy because it's a way reactive metal when it's compared with sodium and lithium. As a result, as you go down, you're going to find the reactivity of the metal increases. So you need to take care when you're doing any reaction with group 1 elements, because group 1 elements, as I have mentioned lots of times, they are way too reactive. That's why all of these metals are placed in oil. We don't keep them in contact with air, because once you keep them in contact with air, they are going to burn, producing fire, as you can see. So we tend to store them in oil. The oil is going to prevent the contact between these metals along with the air, and is going to store them for a longer time. Right now in group 1, we said that when we put the metal in contact with water, it's going to react. Sometimes it burn, producing fire, sometimes it's not, based on the reactivity of the metal. So potassium is the most reactive and is lower down the group. Lithium is the least reactive and it's top on the group. I want you to see that. Yes, we are comparing the potassium along with lithium. Okay, so we're comparing these three together. So as it's down, lower the group, so its reactivity is way higher than the lithium, because lithium is found on top of the group, and we said as we go down, reactivity increases. Perfect. So lithium is the least reactive because it's found on top. Potassium is the most reactive because it's found down in the group. In all three of these reactions, the metal react with water to produce hydrogen and metal hydroxide. So when you place a metal in the water, it's going to produce metal hydroxide along with hydrogen. Perfect. So hydrogen gas will be given off. Other metals, when they are in contact with the water, they don't react with cold water because they are less reactive. So you need to increase the temperature of the water, or mainly make them react with steam. Steam is a water vapor, so it's water in a state of a gas. This gas is going to have a higher temperature in order to make the magnesium react with the water. So not all the metals react with cold water. You have magnesium does not react with cold water. It needs a steam or a high temperature in order to stimulate the reaction between the magnesium and the water to produce magnesium oxide, and it's going to give out hydrogen. When the magnesium and calcium react, they react less vigorously with water because they are way less reactive when it's compared with the group 1. As I want to show you, magnesium, and that's magnesium and that's calcium. So these are group 2. We're comparing right now group 2 with group 1. Okay, so group 2 metals react less vigorously when they are compared with group 1. Perfect. And group 2 react more vigorously, or not more vigorously, but they way more reactive than transition metals. So here is the most reactive metal. Okay, as you move this side, the reactivity increases. Decreases. Reactivity decreases. So this is the most reactive. This is less reactive. This is the least reactive. I hope you have understood the differences between the metals based on their positions in the periodic table. Right now I want you to get your course book on page 83, and I'm going to give you 3 minutes in order to figure out the answers of the course book on page 83. Then we're going to discuss the answers together. Okay guys, the first question, which of these three metals, sodium, lithium and potassium, react most vigorously? So you need to remember the places in the periodic table: sodium, lithium, potassium. Okay, let's figure out the periodic table. Let's figure out the answer from the periodic table. Lithium, sodium, potassium. We said the lower, the highest reactive, and the upper, the lowest reactive. Good. So let's check the question one more time. Which of these three metals, sodium, lithium, potassium, react most vigorously? Perfect. Potassium react most vigorously because potassium is found lower the group, unlike the lithium, which is found upper and top of the group. So in order, we have potassium, the highest reactive, then followed by sodium, then followed by lithium. Second question, write the word equation for the reaction of sodium with water. When you place sodium in water, it's going to produce perfect sodium hydroxide along with hydrogen. So when sodium react with water, both of them are going to be considered as reactant, and sodium hydroxide along with hydrogen are going to be considered as products. Perfect. Then, what safety precautions must be taken when these reactions take place? Oh, so as we said that these are way reactive metals, we need to put in consideration lots of safety precautions that must be taken when these reactions, like wearing the safety glasses. You need to put on a safety glasses, safety goggles. Metal should be moved using tongs. You should not use it with your hand. You carry it with your hand because anytime it can react with oxygen, it might burn in your hand. Only small piece of metals should be used because, as I told you, it burn in the presence of oxygen and water, this producing hydrogen gas, and this is way dangerous reaction. That's why you need to do this reaction when your teacher is around. Only small pieces of metal should be used, as we have discussed. A safety screen should be used, so you need to put it to do the reaction on distance so you don't harm yourself. Next question, explain why these metals must be stored under oil. We said that to prevent the contact between the metals along with the moisture or the air or the oxygen, because as soon as the metal come in contact with the air, it's going to react with the moisture, and this is going to burn it and it's going to explosion if you're using a large piece. Next question, what is the gas that is given off and how would you test for it? The gas which is going to be given off is hydrogen, and you can test the presence of hydrogen by applying lighted split. The hydrogen is going to burn, making a pop squeaky sound. Next question, how could you tell if a calcium or magnesium is more reactive? Then you need to remember the periodic table, and we said in the periodic table, based on the arrangement, you can tell if calcium or magnesium most reactive by measuring which one produces greater volume of hydrogen. That's a way, or by looking at the periodic table. Either of them can be correct, but if it comes to the practical, comes to the observation, you need to monitor the amount of hydrogen gas produced at a certain time. So you're going to measure the number of bubbles that was given by calcium and magnesium at 1 minute. If calcium produces a higher number of bubbles at a minute than the magnesium, that means that the calcium is more reactive, and vice versa. So you can look at the number of bubbles produced at a certain time interval, so you can take a minute in order to measure out the number of bubbles. Next question, what factor should you take into account to make this test a fair test? You need to use the same mass of calcium and magnesium. The volume of water need to be also the same. Temperature of the water should be the same, because changing any of these factors is going to change the result, is going to change the number of bubbles produced within a minute. The last question, write the word equation for the reaction between calcium and water. When calcium reacts with water, it's going to produce calcium hydroxide along with hydrogen. And as you know, calcium and water, these are the reactant, while the calcium hydroxide and hydrogen, these are the product. Perfect. Okay, the experimental question, or the last experimental question, explain using the particle theory why the reaction between steam and magnesium is more vigorous than that between liquid water and magnesium. Okay, the particles in the steam are able to move freely and have a lot more energy than the particles in the water. That's why we said some metals will not going to react with water because they need more energy. That's why we need to react them with steam, because steam is a form of water vapor that has a higher amount of energy. So the particle in the steam are going to collide, are going to hit the particle of the surface for magnesium way more frequently than the water, and this is going to make the reaction to take place. This means that the reaction between steam and magnesium is more vigorously than between liquid water and magnesium, because steam provides enough energy for the magnesium to react with water, unlike the cold water with magnesium. In today's lesson, we have discussed the reactivity between group 1 metals. We have seen how we can increase the reactivity by going down the group, and how the potassium is way reactive than the sodium along with the lithium. And we have seen how to find out the reactivity based on the observation. If a metal is producing more number of bubbles within a certain time interval, this means that this metal is more reactive than the others. I hope you have enjoyed today's lesson, and see you next time.